Hello, Nafis Hassan. Mute yourself, please. Okay, so I'm not going to wait, huh? So it's up to the Nafis Hassan. Can you please mute yourself? Okay.
Sorry.
So when we talk about continuous variable, we are talking about the variable that is measurable. For example, length, time. For example, we want to talk about time taken for a marathon cup competitor to finish the race. Okay, so these are examples. Okay, so now usually when we have a continuous variable, when we plot the graph, we will draw an histogram. Am I right? So here we will put frequency. Yeah, so we'll draw the histogram. So when our table of value, okay, usually, okay, this is my variable x. So I will say from a number, like for example, if I'm talking about the length of a pencil, okay, so I will say 5 to 9 cm. Then here I put frequency, okay, then 10 to 14 cm, and so on and so forth. Am I right? So then I will draw the histogram. So I will draw the histogram. Yep. Okay. Then, got it? So now, for continuous variable, we want to talk about, okay, we want to talk about probability density function. Okay, what do you mean by probability density function? I'm going to explain to you. Okay, probability density function, that means instead of plotting the graph of frequency against the variable x, so now I'm going to plot relative frequency. Relative frequency against the variable x. So when you talk about relative frequency, that means, for example, this one I study, I got the frequency is 5. Okay, the frequency here is 5. Here is 14. Okay, I just put 3 classes. Okay, put 4 classes. 15 to 19, I have 7. Then 20 to 24, I got 2. So what is the total? What is the total? Hello, what is the total?
Is it 28?
Yeah, 20, yeah, 28, right? So when I say relative frequency, I can put it as a percentage, or I can put it as a decimal. So relative frequency means like that. In total, I have 28. So this one is 5 over 28. This one is 14 over 28. And this one is 7 over 28. And this one is 2 over 28. So I got this. So total up, So it is not the probability, it is the frequency. So then I draw the histogram like that. So now this one is 5/28. How much is it? 0.17. Okay, so here is 0.17. Okay, then this is 2/14 divided by 28, half, 0.5. So here I put the histogram. Here is 0.5. So this one is wrong. This one should be shorter. Taller, then this one is shorter. Okay. So then after that, I plot another one. This is 0.5 and 7/28. Yeah, just use calculator. Okay, 0.25. So it's somewhere here. Okay, then 2/28. This is 0.071. So it's way down here, right? Okay, so this is the one. So if I increase my number of study, so I can come up with a smooth curve. Okay, so the function for this curve is called this one, probability density function. Are you clear? So this is what we want to talk about. Yeah. So whatever value shown here is the relative frequency. Got it? So bear that in mind. Okay. So this is how we get to this probability density function. Okay, now, so may I ask, if I want to ask about probability, what is the probability? Okay, what is the probability of getting x equal to a number? The chances is very, very unlikely, correct? Probability of x equal to 5.001, for example. The chances is almost equal to 0, correct? Yeah. So if you go and measure the length of a pencil, can you get a pencil of this length? The chances is very, very unlikely. So to find the probability of something happen in a probability, if I give you a probability density function, that means you must find the area bounded by the curve. So now we want to talk about the key point of probability density function. Hello? Can or not? Do you know how probability density function is got it? So
Wait, what?
we are plotting relative frequency against the variable.
And from there we can from the what's it called, the curve,
So
right? We can see the probability for any length, right?
Yeah, you go and find a formula to fit it, to fit this function, to fit this curve.
So now we're trying to find the formula for this curve.
No. The formula is going to be very complicated. Later, I will send it to tell you that if you have this kind of curve, how complicated the formula is. So we are not going to. So I'm not going to show you the real situation probability density function curve.
So most likely it will be given or simplified.
No, I won't give you the formula. No formula is given. Okay, but I will give you something which is simple enough for you to be able to do at this stage.
Okay.
Are you clear?
Yes.
Okay. So every time the question will give you a probability density function. For example, I say given, okay, the fx is the probability density function for a variable x. Okay, so if fx is a probability function for a variable x, so now if I define like that, fx is equal to yeah. Okay, let me show you a graph first. Oh. Don't worry, don't worry. Okay, so okay, so 1/25x for x between 0 and 5 and 0 otherwise. So I give you a probability density function. Okay, so this is the probability density function. So you have to fulfill certain criteria. So first of all, first one, you have to check for all values of x. The probability, the density function, the probability density function, the value must be greater than or equal to 0. This one satisfied or not?
Yes.
Yes. So it's all above the x-axis. So this is the first one. It must fulfill this. If it doesn't fulfill this, then the key point, like when we talk about binomial distribution also, correct? Key point, first one, it must satisfy this. For all values of x, fx must be greater than 0. Fx is the probability density function, is the relative frequency. Okay, now, second thing, we know that total probability must be equal to what? Must be equal to
One.
Equal to 1. So for this continuous variable, if you want to find the probability, you have to find, okay, to find probability for a certain range of x to happen, we must find the area bounded by the curve.
It means what is center range again? What is center range?
Certain. T-A-I-N.
A certain range. Okay.
Sorry. Certain range of x to happen, we must find the area bounded by the curve. So which means that for all these, others are 0 means here. So for all this, so that means this area, what must be the value for this area?
more than 0.
Huh? How can be more than 0? Hold on. So, can you tell me what is the value for this area? It must be what?
Positive.
Total area must be what? Must be?
Positive. Or
Must be?
less than
1.
Must be 1. Yes. How can be less than 1? These are all my possible value for x, correct? So if I find the total area, it must be equal to 1. So you have to check. If not, it won't be a valid probability distribution, probability density function. So now, is it equal to 1? This is a triangle. Half base times height. So is this a valid equal to? Equal to what? Half base times height. 1/5. So I got half. So therefore, this is not a valid probability density function given fx. So it's not a valid probability function. So remember, it must be equal to 1. Hello? So you must check these two. It must satisfy both. Then it's called a probability density function. So this one, is it a valid one? Hello?
No.
But if I change it to here, if I put it like that, this is 5, and I put here 2/5. And the rest are 0. Then is it valid? So for this one, it will be valid. Half base times height. So I get 1. So this one is valid. So you have to, every function that I give it to you, you have to check whether it's valid probability density function or not. Clear? So these 2 key points. Done? Then I'm going to quote example, and we are going to first decide whether it's a valid or not valid. Right? Hello?
Miss, when there's a question about the function itself, what is like 1/25x, the range? What does that mean?
What am I?
For
I'm giving, after I will explain this.
Oh, okay.
It's based on this graph I got that. That means from 0 to 5, I use this formula. Other than that, I put 0.
Oh, okay.
That is how you read. That means these are piece function. That means for certain range of value of x, I use this function. Then another one, I use another function. So it doesn't mean that one function for all. You get me?
See.
Okay. Done? So you have to test. Okay, I'm going to test your understanding. So now let's look at this example. Okay. If, for example, I give you a proper function like that. Hold on. 0.6 divided by 3. Okay, I give you a function 0.2 x plus 0.6 for x between 0 and 4. Okay, then 0 otherwise. That means all the other value of x, the probability, the density, the function will be 0. Okay, now, is this a valid probability function? Oh, sorry, this is negative. Okay, can someone tell me, is this a valid probability density function? Okay, I have a friend who said no. Why not? Explain, why not? Can you use your GC and sketch this graph?
Is it because when x equals to 4, the function is below the graph, the x-axis?
Yes. No, because when x equal to 4, my F4 is equal to negative 0.2 times 4 plus 0.6, which is negative 1.4, which is less than 0. So do you see how? So if you sketch this graph, the graph will look like this. Here is 0.6. It cut through here. Here is your 3, and here is your 4. So for x between 3, so you can also sketch the graph already. Then you say for x greater than 3 but less than 4, fx is less than 0. So test the first one first. Okay. Today I have no time to ask you question because I want to teach the thing. Okay. So example 1. So you see. Okay. Now I'm going to give you example 2. Okay. Example 2. I give you this. Okay. Up to me how I want to name my function. Okay. Justify whether this is a valid probability density function or not. Okay, x between 0 and 4. Is this a valid probability density function? Okay, you can sketch the graph first. So when you sketch the graph, do you know how to use your GC to sketch the graph? Yeah, you just key in this into Y1, then you put your domain at 0 to 4. So you will get a graph like that. Then others are 0. It can be left, it can be right, it doesn't matter. So the first one, hx is more than or equal to 0 for all x. Right? So first one, okay. So can I say it is valid? No, until it satisfied the second one. So now, I know that total probability must be equal to 1. So now I find the total probability. We know that we want to find probability for this case. What do? We find the area bounded by the curve.
Miss, I think your graph might be wrong.
Yeah,
think it's
miss.
a
I got
negative.
different graph.
It should not be
Should be
that shape.
negative. Right? Oh.
I should put a negative there. Sorry.
Yeah.
So sorry. I should put a negative there. Yeah. So total probability. Okay. So now I count the area. Half base times height. So I got 0.6, not equal to 1. So valid or not valid?
Valid.
Huh?
Not equals to 1, right? Not valid, or it's not valid.
Total probability must be 1. Now I don't get equal to 1.
I say invalid.
So invalid. So now you understand? Okay. So the next one. Okay, the next one I'm going to give you a valid one. Then I'm going to teach you how to use this to find mean, mode, median, and so on and so forth. Okay, third one. Okay, so I'm going to give you kx. Okay, 0.075 x plus 0.1 x between 0 and 4. 0 otherwise. I try not to make it complicated for you first. Okay, now is this a valid probability density function? So we sketch a graph. Okay, that is the best way. So the graph that we have, others are 0. Here is your 4. So start from 0.1. You go right up to here. Hey, I hope you all know what am I doing. Okay, what is the value here? When x equal to 4, what is the k for? Hello? Is it 0.4?
0.4. Yeah.
Yeah, 0.4. Okay, so now, so based on this graph, we know the first criteria is kx is greater than or equal to 0 for all x. So, okay. Number 2, area bounded by the curve. Okay, so this is a trapezium, correct? To get the area of a trapezium, sum of the parallel height times by the length. Yep. So we get 1. So this is a valid what? Valid probability density function. Clear? Okay, now, so if the question, so now I want to talk about how to use this to find the probability and the mean. Okay, now, we know that the area bounded by the curve represent the probability, correct? So now if I want probability for x to be equal to 2, for example. So you want to find the area bounded by the curve, you must integrate, correct? Yeah. So if I say equal to 2, that means the lower limit is 2, the upper limit is also 2. Am I right? Am I right?
Yes.
So what will I get? Integrate from 2 to 2 kx dx. Do you think what will I get?
0. Probability less than 1.
Definitely 0. Yeah?
Yeah.
obviously is 0. That means for continuous variable, the chances for a particular value to happen is 0. So that is the first point. Clear? Hello?
Yeah.
Okay, so now if I want to find the probability of X between 3 and 5, okay, it will be the same if I say like that. Whether got equal, no equal, it doesn't matter. Okay, now, since I got 2 pieces here, so if I want to find the probability, I have to integrate from 3 to 4. The function is 0.075x plus 1. Because 0 to 4 follow this formula. Plus 4 to 5, others are 0. Okay, so the chances for this to happen is definitely 0. So now you can use your calculator and get the answer. Can you please? You still remember your FNINT, right? So now you know how to find the probability, huh? Okay, got the answer? This is definitely 0, okay? Because it doesn't depend on X. Okay, what is the answer? Can someone give me?
0.3625.
Huh? Yes,
3625.
0.3625.
Yes.
Is that correct?
Yes.
Yes.
Okay, good. So you remember, you got your calculator very easy. Okay, so first thing, remember this particular value to happen is impossible. So got equal sign, though, equal sign still do the same thing. Yep. Okay, third, how to find the mean? Okay, so mean, you have to integrate x kx dx. So this is the formula to find the mean. You have to add on. So that means from 0 to 4, I have to put x. And if you key this into your y1, you just write down there y1. So in exam, you can do like that. If you got how many formula, you just say, okay, then the other one, otherwise, because it's 0, so you don't have to bother. Yeah, so equal to. So can you please key into your calculator and get the answer? That is how you count the mean. Because in discrete, we say mean time probability, correct? So this is x time probability. So this is x time relative frequency. Is the function, okay? So what do you get?
2.4.
Huh?
2.4.
2.4.
Yes.
2.4, huh? Exactly.
Yes.
Okay, that is good. So how to find the mean, huh? Got it? Okay, now how to find the median? How to find the median? Okay, the mode you know is 4. Why I say the mode is 4? because that one have the highest relative frequency, correct? So the mode is 4. Okay. How to find the median? What do you mean by median? Since I have only one formula, so I must say, if I integrate from 0 to m, m is the median. For this one, what must the probability be? Median is 50% more than that, 50% less than that, correct? So what must this value equal to? Can someone tell me what must this value equal to? Hello? Class? Hey, median, 50% more than that, 50% less than that. So what must be the sum of the probability from 0 to the median? So if here is a median,
2.
what must be this area be? 0 point?
0.5.
Yes. Why are you all so scared to tell me that? Okay, so now what you can do with this is, you don't have to solve it manually. You can use your solver. So try to use your solver and get this answer. Still remember how to use solver? Go to your math. Solver. Yeah, E1. This is your E1. And this is your E2. Okay, faster. Your M, you put X, huh? 0 to X. Then 0.075 X plus 0.1 and dx. Then your E2 put 0.5. Then okay. Okay, so now there is a X value come out, correct? So please,
Yeah.
your X must be between 0 and 4. So just put 3. Then put alpha, enter. So what is the median your calculator give you?
2.554.
Yeah, 2.554. You want to check whether that answer is right or wrong? You can go to math, then you go to FNINT again, you check. If you integrate, see whether you got 0.5 or not. Yeah, you integrate from 0 to 2.554. You want to check, 0.075 X plus 0.1, then dx. Yeah, I got that. So now you know how to find median?
So it's always equals to 0.5. Always equals to 0.5.
Why always equal to 0.5?
Because
Rachel, you tell me.
median is the middle number when arranged numerically.
You keep saying middle number, no use. If you keep saying middle number, it won't give you the sense of probability. How I get the 0.5 there? Just now, what did I say? I said 50% of the number of the value of X will be more than that number. 50% will be less than that number. That means if I count from 0 to M, the probability should be 0.5. When you say, yes?
So I'm sorry, but can you repeat how you change the 2.5 to 2.554?
Huh?
I did the solver, but then I got 2.5. So
2.5 exactly.
yeah, Cha, I think I made a mistake. So can you please repeat the
No.
steps?
When you go to your solver, okay, first of all, your solver will, the first number appear in your solver, correct? It's not the answer yet. When you max, you go to your solver, correct? After you key in your E1 and your E2, am I right? You press OK, correct? Whatever come out there is not the answer yet until and unless you press alpha enter. Then they will search for the answer for you. Did you do that? When you
Oh,
have
okay.
do you get me? So that
Yes.
is how you use your solver. So solver is very important here. If you want to do it manually, you are going to go crazy. Okay, next.
Thank you.
Yeah. So we talk about this, we talk about median. So now we want to talk about how to find standard deviation. So standard deviation, the formula will go like that. So this one, all you have to remember the formula. Okay, number 4, number 5. Okay, standard deviation for x. So it's square root, integrate x squared fx dx minus mean square. So this is the formula. So for our case here, we will do integrate 0 to 4 x squared times by your 0.075x plus 0.1 dx minus, just now we get the mean is 0.3625 minus 0.3625 square. Then you get the standard deviation. Are you clear?
Yep.
Hello?
Yes.
Okay, Okay. So you should be able to do your exercise 8B.1, 8B.2, that kind of thing. Okay. So I will run through one examples. This example are things that it may ask in your SAT 5. One of the question definitely will involve this. So all the formula I listed down here, you better list it down. Okay. So now I'm going to give you a probability density function like this. Can we? Okay. So I'll give you fx is the probability density function. Okay, this one got 3 pieces. This is definitely a valid probability density function, okay? By the way, this is x, Okay, otherwise, that means the others, okay? Okay, so now, first one. I want you to sketch this probability density function. So how are you going to do it? How are you going to do it? Anyone, any suggestion? So what I will do is, listen, every time when I have more than one function, I will denote in my question, I let this be my y1 and let this be my y2. Okay, I key into my calculator first. Okay, key into your calculator. Key in already. Key into your calculator. Make sure you unhighlight your plot. Make sure you unhighlight your plot, please, class. Unhighlight your plot, then you go to window. Now everyone in window, set the x minimum as 0, x maximum as 5. Then go to zoom. Zoom what?
Fit.
Yeah, zoom fit 0. Okay. Did you see your calculator come out like that? The blue one. Then the other one, the red one. Do you get that?
Yes.
But, okay. First of all, your blue one is only from 0 to 3, correct? 1, 2, 3. So may I know when x equal to 3, 0.1 times 3, I only get 0.3, correct? So it is until here, until this point. So the blue one. So you only take from here to here. So when you sketch your graph on your question paper, one, two, three. So you sketch until here, you stop. Okay. Then from 3 to 5, when x equal to 3, okay, negative 0.275 times 3 plus 1.35. What do I get? I also get 0.3, correct? Do I?
Yeah.
I hope so, because I scared I do the wrong thing. Wrong, no, I'm wrong. My equation is wrong. No, I shouldn't get 0.3. I got 0.525. 0.525 wrong already.
Yeah. That goes half a page.
Wait, 0.525. I should get 0.55. Wait, it doesn't matter, 0.275. I just need to change something on it, it's okay. 0.275. Hold on, 0.275 times 3. Okay, 0.275 times 3. Plus 0.55. 1.375 here. Can you just change here? Can you please just change there 1.375?
Okay.
So you go to your Y2, you just change to 1.375, okay? One number different, everything different. Okay, so I go to graph. Yep. So here you get 0.55, correct? So you go up here, 0.55. Then you go down here and you end at 5. So your graph will look like this. You get me? Hello? So 2 pieces. Yeah. Okay or not?
Yes.
Okay. So now if okay, so now if I want to find the mean, okay, so from here, if I want to find the mean or if I want to find the median, then I have to study more. Okay, so now if I want to find the mean, so what should I do? I have to break into 2 pieces, integrate twice. Yeah. So to find the mean, so I have to write the formula, integrate from 0 to 3 x times y1 dx. So if you, in the question itself, you denote what is your y1, what is your y2, over here you don't have to repeat. Plus 3 to 5 x y2 dx. Then you get the answer. Okay, but if you want to find the median, standard deviation, you also just follow the probability, you just follow accordingly, okay? But if you want to find the median, that is the tricky part. You have to check. You have to check where is the median, the first formula or the second formula. You have to check. So what I do is, I will integrate from 0 to 3 y1 dx first. Can you please integrate that?
Okay.
And tell me the answer. Actually, I don't have to. I can straight away tell you the answer. The answer is less than 0.5. Am I right? Hello?
Yes.
Class? So what is the answer? Okay, 0.45. So where is the median? So the median is definitely someplace somewhere here. Okay, so that means this area will be 0.5, right? So what I can do is, I can now, instead of 0 to the median, so now I can say from median to 5. From median to 5, y2 dx. It must be equal to 0.5, can or not? Then I use my solver and get the answer. Okay, can you please now use your solver and get the answer? So median is a bit tricky if you got more than 2 pieces of function.
We check like the first piece to make sure it's below 0.5.
Up to you. You want to check the first piece, you want to check, up to you. It's okay.
Also,
Whether
as
you want-
we just check one of the pieces must be below. Okay.
Yeah. But you must know how to interpret that. That is the most important one. X to 5, y2, you call out your y2. Since you got your y2, still remember how to call out y2 or not? Alpha
Yeah.
trace, huh?
Alpha trace.
Yeah, then okay. Then you must put in the correct number. So the X you put in 3 point something or you put in 4. Then you put alpha, enter. then it will take some time, then you can relax. Is it 3.09?
Yes.
So median 3.09. So are you okay? So I'm trying my best to give you all the possible. So first of all, you have to check the validity first. Can I not check the validity? How to check? I'll show you. So how to find the probability? Find the area bounded by the curve. If there are more than two pieces or more for the function, then you have to do it carefully, especially for the median.
Miss, what's the
Okay,
proper way to like interpret that?
Huh?
What's the proper way to interpret like one
So
of the
I
pieces?
will say that 50% of the value is more than 3.09 and 50% of the value is less than 3.09. That is how
Okay.
you interpret median. Okay? So please, this weekend, please try to do because that means I finished 7B. 7B. So 7C, normal distribution. Yeah. So by next week, I definitely can finish and do some revision already. You get me?
Yeah.
Okay. So that means I've covered 3 questions for your SAT 5. Your SAT 5 will have 4 questions. I've covered 3 questions already. You can go and have a look at the practice test. Are you okay?
Yep.
Okay. Thank you, class. 3 o'clock already. You have to rush for the other class already.
All right. Bye, Miss.
Thank you, Miss. Thank you. Thank you, Miss.
Yeah.
Yeah. Hello.
Yes.
Yeah, I was late to class a bit earlier and it ran out of time for me to type in the code. So
You come into the class late,
yeah.
Frederick.
Yeah.
So it's not don't have time. You come into the class late. Am I right?
Yeah.
Yeah. So next time, please don't do that again. If you don't do that again, then I'm not going to mark you present.
Yeah.
Okay. Okay. Thank you.
All right.
I will do the adjustment.
Thank you.